recording those who wants to listen later. Okay, we have already 10 students in our classroom. I'm going to show you first the syllabus. I've been thinking it's almost 14 weeks we are going to discuss energy policy, talk about energy policy, 40, 40 or 13 weeks. Anyway, it's almost approximately 45 hours. It's going to be teaching sessions. However, I've been considering at least average 2 hours you are going to work or you are going to study the topic after the class. So I predicted 28 hours would be necessary for you to prepare your home assignments, to prepare, understand topics and things like this. Okay. There is no single textbook. Since, of course, there are books. However, there is no, this is a very wide topic. Therefore, there is no single textbook. And every year I follow the international material published. The funny thing is this. If you write a textbook for example, power electronics control, of course, there are some improvements occur during the period of 5 years or so. So you have to slightly change your book in order to put the new topics in it. All right, this is fair. However, energy is not something like this. Every year figures are changing. Therefore, the major points we have to discuss. For example, energy policy also directly linked with the financial matters as well. Direct link with cost. Therefore, I'm going to also give you some information about the financial part of it. My students generally know that what GDP is all about, gross domestic product, GDP. In Turkish, milli gelir. So whatever you buy, whatever you sell, or you transport it, so you provide a money transfer. Then at the end, it covers all the budget of the country. That is called milli gelir, or in other words, gross domestic product, gross domestic inner product, and gross domestic product, GDP. All right, gross domestic product. So what is, for example, what is the gross domestic product of Turkey? You are going to know that, but first of all, you are going to learn which country is the number one in the world. Probably now you can look at your cell phones through Google. You are going to realize that the United States is number one. And $1 trillion is discussed. You see, Turkey's gross domestic product is somewhere 850 billion, milyar in Turkish, billion Turkish, dollar, US dollar, but or let's say $1 trillion. All right, but United States is somewhere 20. If you look at the final figure, it's changing all the time as well. Every year, world total product is increasing somewhere between 3%, 2%, 1.4%. Therefore, every year is getting up. The wealth is getting up. Of course, it's not our topic. Although the wealth is getting up, but sharing the wealth is getting down. That's why there are a lot of conflicts occurring between, the societies in our countries and also other places as well. Some people are very happy, some people are very unhappy, but that is not my job. This is not. This course is not involving United Nations discussion points and things like this. Equal opportunity, equal, also sharing the wealth equally and things like this. It's not my course, but we are all aware of the fact that energy policy is directly linked with the money. So you buy the cheapest energy. If you are going to buy the energy from outside, some countries are producing energy, some countries are also consuming energy. As far as Turkey is concerned, we are in the consumption part. We consume the natural gas, we consume petroleum, we consume, even we buy coal from outside. Anyway, but Saudi Arabia, for example, Iran, Iraq, Kuwait, Venezuela, these countries, even Algeria, Nigeria, these countries, and United States now is net export. These countries are produce more energy, crude oil, for example, petrol, crude oil. Anyway, so we are going to discuss. Let's concentrate on the syllabus. So you are going to attend the course. I always take the attendance list. The course description. Plagiarism. Do you know what plagiarism is? It is Turkish and Arabic. It's to say there is the same word, intihal. Taking something from someone, using someone's knowledge, written material, but without giving a reference to him or her, and acting as if it's your own material, acting as if you already provided that knowledge by yourself. This is, of course, is a kind of thief. You're stealing something, stealing knowledge. All right. Yeah, cheating. Cheating is a wide word. Someone says cheating. Yeah, that's right. Plagiarism is a good word, and if you complete, for example, a thesis, we send the thesis to the place where they are controlled plagiarism, and then they send us how many percent of the thesis is copied by. Of course, there are some other sophisticated methods developed in order to avoid plagiarism. ChatGPT, for example, is one of them. ChatGPT is very clear. So they provide thesis, for example, without any plagiarism. However, we are in the position to, since we know the publications and material, then we understand the case. Anyway, course description. Scales of energy policy. Of course, main issues of energy policy. Follow my cursor, please. Scales of energy policy, the parameters affecting energy policy, primary energies, fossil fuels and renewables, environmental issues and sustainability, the secondary energies, and the major secondary energy is electrical energy, by the way. I'm going to give you some primary information right now. And the electrical energy production, transmission, and distribution. That is, this is the major part. I always follow energy figures, and more than probably 30 years, I have prepared a lot of reports about energy for Turkish government, university rectorships at Istanbul Technical University since then. So I know the weight of the electricity. The weight of electricity is increasing every year. Petroleum, coal, natural gas, these are primary energies, and these are major fossil fuels. However, now electricity is getting more and more, although it's a secondary energy. You burn down the coal, you produce heat, then you produce steam. That steam produce pressurized water, let's say, or pressurized steam. Then turn the turbine, rotate the turbine, and then when turbine rotates, it's connected to generator, produce electricity. That's why it's called secondary energy. But electric energy consumption every year, or the ratio of electric energy consumption, is increasing anyway. Nuclear energy is also important. It's a totally different types of energy. Anyway, but electric energy production, transmission, distribution, and utilization. Of course, energy efficiency is important part of our course. Energy transition, dönüşüm in Turkish. Energy is now more and more electric energy is used. More and more intelligent energy is used. Cost of electrical energy, of course, is another major, very important part of our course. Carbon dioxide emissions and new global energy policies. The net zero policy, for example, although it's a bit utopic. Not all the countries are obeying that net zero policy. But generally, it is accepted that in 2050, the carbon is going to be leveled. So people are going to produce net zero, means net zero carbon actually in 2050. One of the worst country as far as emissions are concerned, India. Another one was China. China has changed its policy now towards clean energy. Now it's improving. Even United States, for example, 10 years ago or 15 years ago, United States, the houses were big, cars were big, energy consumption per person was very high. Now they are also a lot of petroleum consumption, a lot of coal consumption. Now even United States has accepted the clean energy policies, and the energy policy in which level we are going to discuss. So these are topics we are going to discuss. And at the end of this course, I simplified the learning objectives. Of course, you will be able to understand the technical, economical, and policy aspects of the energy. Of course, policy means you well aware of the fact of technical issues as well as the economical issues. The second one will be able to write reports. You can write reports about. Some of you are going to join the government institutions in Turkey or possibly in your countries when you go back. then of course, then you are going to prepare reports about it. So you have to be carefully understand the energy uh, priorities, the technical subjects, and the other energy policy issues. And also, you are going to express yourselves orally. You can express yourself. You are going to present a report to me. So I'm going to invite you at the end of the term. I'm going to invite you to prepare a report about the energy policy. Course content. Of course, we are going to start with what energy policy is all about, the global level, state level, municipality level. Municipalities are very important. Belediye, company level, even family level. Uh, but the major game changer actually are governments. If governments provide incentive in Turkish teşvik, if government provides incentives on clean energy, which now doing it in Turkey too, then of course people are changing their policy and then they are trying to get more and more clean energies. Parameters affecting energy policy. What kind of parameters affecting? Energy supply and security. Energy security is very important. As I told you, it's a major number one issue, energy security. Global warming is of course, very important. Of course, reserves, prices, cost, other geopolitical issues. And for example, we are receiving some, let's say, I don't know what kind of uh, percent we get, but we get some uh, energy is transmitted, and we get some kind of natural gas which is squeezed, pressurized, squeezed, and became liquid and put it in a tank. And the big ships are carrying those natural gas. In which direction? Qatar, for example, is one of the major natural gas source, and the Qatar we send our ship there, and they fill it, and then what are we going to do? We are going to get it from Qatar through Hormuz. Hormuz gate is important point as far as energy is concerned. Then we get it from south of Saudi Arabia. Then we get in the Aden, um, so very near to Yemen. Of course, there's a problem in Yemen. Then some ships are avoiding, most of them now, avoiding through Suez Canal, through Red Sea. They change their direction and come to Jebel Tariq, uh, Algebra. Uh, sorry, I couldn't remember the English name of it. Of course, you all know Jebel Tariq. Then get in the Mediterranean. So it cost of it is getting higher. So that means that geopolitical issues are very important since there is a war between, in that region, not be, but uh, in Yemen, of course, is involving the war. So it's increasing the cost of the transportation. Carbon dioxide emission total and per capita. Per capita means per person. So that's very important. If country is very big, you produce a lot of carbon dioxide, but what about per person carbon dioxide value was it? Energy mix is another point I'm going to teach you while you are producing electricity, for example. It's becoming very important. This course is very exciting, by the way. If you enjoy the course, it's very exciting. It has money in it. It has, of course, it's a technological issues in it, but it has money in it. It has even political issues in it, and it has environmental issues in it. It's enjoyable course, and it gives you hints for your future career. Then definitions, I'm going to give coal, oil, natural gas, shale gas, and things like this. Renewable energies, I'm going to give hydrogen. Hydrogen is important. Be careful about it. Nuclear energy is still important, and there's a revolution occurring in that area. They call it new small power nuclear power stations are going to be much cleaner. Of course, some people say nuclear energy is dirty energy. It is not dirty as far as you avoid any accident. But if you have an accident, then problem starts. Big problem starts. But as far as carbon dioxide or the other greenhouse gases emissions is concerned, nuclear energy is clean. Anyway, transmission and storing of energy is another major issue. Energy conversion is also another issue. And utilization of energy in industry, transportation, buildings, this is also final issue. Energy efficiency is also a very important topic. Now I go back to my presentation. Is there any question about it? Devam var, bir dakika. I mainly read British Petroleum reports rather, and International Energy Agency reports, but also the United States Energy Department for Energy, and their institutions are very good, and also other sources we have. We are going to look at those. Electric energy topics, of course, we are going to study the electric energy utilization costs. For example, if you are going to define a policy, you are going to install an electric power station. What are you going to do? You have options. You have nuclear energy source. You have coal fired. You have natural gas fired. You have rivers. You have dams, big hydropower, and also you have wind generators, and also solar cells now, solar panels. Geothermal you have is naturally coming. Of course, it's not naturally, but when you do it, it comes up without any further energy consumption. The gas, some kind of gas, heat, and water, hot water comes up. It's geothermal. And also we are going to look at the electric energy topics where we have transportation, industry, and residential. All right. We are going to lecturing in OLearn Blackboard system, and also I'm going to put teaching material OLearn. You are going to prepare one final project. We are going to have one midterm exam, and I expect one final exam. Okay. These are the materials we have. Generally speaking, I think it's 50-50. midterm studies 50. Just a moment. I may change it, this one. If I give a midterm homework here, 10 point, then it becomes 50, and this becomes 50 as well. So it might be 50-50 as well. I might change it. I haven't decided yet. Okay. By mistake, I dropped system. Now you can see me again. Can you? Okay.
I have a question, Hocam.
Yes, please.
You said about the grade distribution that we will have a mid and final, right?
Sorry. Can I have another? Can you repeat the question again?
You said about the grade distribution. We will have mid and final, right?
Grade distribution. How do you mean grade distribution?
You said that we will have mid and final, so it will be a mid homework or project, and it will be a final project, right?
Yeah, that's right. There would be a final project. You are going to prepare a policy for a country. So it's going to be a final project. It's going to be in replace of the final exam as well.
Instead of final exam, or there is a final exam also, you are saying?
I'm I intend not to make final exam, but I'm going to follow the progress of the course and the let's say contribution during the progress of the course. I would like to see the contribution of yours. Uh, if I realize that online course is something uh, difficult, particularly for student point of view, since during the class, lecturer is active and you can see him or her, and he or she can see you as well, and also directly can ask direct questions to yourself and try to excite you. However, online course, it is impossible to do that. I don't know, for example, now how many of you are actively listening or how many of you now actually reading something, a newspaper, for example, or sleeping. Open up the classroom and then sleep. You never know. We have already 14 students. In order to keep the level, let's say, higher, I generally open up quiz during the let's say questionnaire during the progress of the course, and I ask you time to time some questions. I I might use that method to get probably uh, midterm for midterm success. I might add that one too. Is that all right? At the end, however, I'm going when you learn the major issues about the energy policy, then you are going to define energy policy for a country. I'm going to select some countries. Not all the countries you can get the data. So I'm going to select some countries. Then you are going to prepare an energy policy for those as well. But one thing I would like to tell you now. I'm very old in energy policy business. Al Gore, probably you know his name. Al Gore is the deputy president of the United States many years back. And he was very anxious about the clean energy in United States. United States is one of the big consumers. And then uh, in Kyoto, people come together. I don't exactly remember the date, but it was before 2000. Okay, before 2000. In Kyoto, they have decided that they are going to reduce the carbon dioxide in Japan. It's called Kyoto Protocol. When Al Gore was a deputy president, then president retired. Then there was an election between Bush and Al Gore. Al Gore was the candidate from Republicans. Bush was the sorry, Democrats. Al Gore is a candidate from Democrats, and Bush was candidate for the uh, Republicans. Generally speaking, Republicans are mainly involving central United States, rather conventional people, and Texas region and things like this they are very strong. So linked with the petroleum cartels and things like this. And Democrats are mainly located in the Boston region and and California region. So, however, in Florida, only 100,000 votes caused the change, and Bush won. Bush didn't care about the clean energy. Bush also didn't care about the other things as well. You see, energy is directly linked with the political issues as well, or political issues directly linked with the energy. Bush then, together with the British Prime Minister, they come together and they said Saddam in Iraq has got chemical weapons, so we have to attack them. In United States, people talk about this, but in the meantime, Bush never cared about the clean energy, so the United States changed its policy. So that Bush caused war in Iraq and collapsed all the regime in Iraq. Now we have very difficult divided. Iraq is divided by three now, and it's many people died. Some some says million people died. Forget about that one. But of course, the energy. Iraq is one of the richest country as far as the reserves of petroleum is concerned. So it interrupted as well. However, in the meantime, the energy prices went up, the petroleum prices, and of course that's good for other political, let's say, sides of the United States. Then years back, of course, Bush has completed his term, two terms, 8 years, I think it's 4 year plus another 4 year. Then Barack Obama, I think, came. Arada Clinton da vardı. Neyse. At the end, Democrats are generally clean energy. They have a clean energy policy, and the Republicans doesn't care about. They don't care about the clean energy business. But now United States has changed its policy as well. That's why I would like to emphasize that even the leaders are very important to shape the energy future of the world. But now people understand that temperature rise every year is continuing, and it's becoming above 1.5 increase. Probably, I'm going to ask you now a question. Probably you have heard about 1.5 degree temperature rise business. Everywhere they talk about it, 1.5 degree centigrade. But from which level is going to increase? Is there anyone among you who is going to tell me on top of what? What they all say 1.5 centigrade increase, but what is the reference? Which reference they correspond to? Is there anyone who is going to give me? I have no answer. Yes, I can answer that one. Generally, people are thinking that the starting point is the starting of the Industrial Revolution. You remember that Industrial Revolution is actually started with James Watt's steam engine, invention of the steam engine, which hand power or horsepower is replaced by the motors. First steam engines, then electric motors, and also a lot of energy consumption, coal mining, okay, because you see, in order to provide the steam, you have to burn something. Then you burn down the coal. All the ships were using coals and others. The electric production was using still is coal firing. So the temperature level, average temperature level, is assumed that level starting point is assumed beginning of the Industrial Revolution. So after Industrial Revolution, which is, let's say, uh, 1750, or beginning at the end of the 1700 means 18th century. So beginning of the 19th century, let's say, is a reference, or mid of the 18th century. Since then, 19th century we have, 20th century we completed. Now we are in the 21st century. So more than almost 3 centuries, the temperature is rising. This level is now very near to 1.5, and it is, latest reports say that it is going to exceed 1.5, and that is very dangerous. Who is going to interpret if the average temperature of the global temperature level of the world becomes higher than 1.5? What's going to happen? What kind of effect we are going to see? Who's going to interpret that one? Who's going to give me information? You can, if you want, you can open up your microphone as well. If you are in the clean place, I mean silent place, or you can write. Yahya says the world will sink. Yeah. Of course, you are right, but it's a bit exaggerated. Baran says extinction of some animals. Yeah, it's going on because the poles will be melted. Yeah, you are right. First, starting from the not only the poles, but also the mountains has got a lot of reserve, ices, so they are melting down as well. Because of that one, sea level is increasing. Some islands disappearing, some very level islands disappearing. However, in for example Venice, Venedig in Italy, they also have problems. So rising the level of sea is dangerous, of course, not good. But also we have now more gales, more storms, more heavy rains and floods, sel, fırtına falan. Bunlar daha fazla. We have more gales, storms, and also heavy rains, drought, kuraklık çocuklar, drought. Heavy rains, then without any rain. Some regions have heavy rains, some regions. However, the other parts haven't got any rain at all. So the balance of the let's say meteorological structure of the earth, or global of the world, is changing. That's dangerous. That's why now, particularly the United Nations every 2 years they prepare meetings called COP. COP 28 was in I think either Qatar or United Arab Emirates. I don't know. The one before was in Egypt. The one before was in Glasgow. But the major one was in Paris. The Paris, it was 2015. They all signed that. Governments are signed that. Even the President of the United States signed that. They are going to change their policies towards net zero level in 2050. Anyway, I know you are tired a little bit, so let's start enjoyable part of our course. Uh, I'm going to change those, of course. 23, I have already downloaded the 23 World Energy Outlook and also International Energy Agency World Energy Outlook. Uh, and and also these are the energy efficiency reports, digitalization of energy. Energy transition is also important. It's giving you a lot of opportunity. New jobs will be available. Energy transition. There are two ways energy transition. Listen carefully. Two ways. One of them is clean energy. The other one is digitalization, digitalization of the energy. So more and more intelligent methods are used, and digital methods are used to produce electricity, to produce energy, to transport energy, to use energy, increase efficiency, and everything. So two directions: production, clean, and the other one also the artificial intelligence or clean, clever energy methods are increasing. Anyway, the United States energy reports are also be obtained from there. Can you read the question? Questions rather. Do I know primary energies? Do I know their cost, sorry, their units? Can I convert them? Do I know secondary energies? Now, of course, you know the primary energies. Coal, natural gas, and petroleum, oil. These are fossil fuels, major primary energies. Nuclear is a kind of funny, but might be primary. But also there are some clean primary energies as well. Wind is a primary energy. Solar radiation is a primary energy. Tidal uh, or wave energy, these are all primary energies. Their form might be in a chemical form. When you burn it down, it becomes secondary and produce heat. Heat is also energy, and the secondary energy is main secondary energy is electricity. Do you know the units, by the way? Who is going to tell me energy units? Bir söyleyin bakalım. You tell me energy units. Birisi yazdı. Joule. Good. The starting point is Joule. Yahya, is what energy? Are you sure that what is energy? Yahya, be careful. What times time is energy? What second? Or what hour? But what is a power? Okay. Joule is what second, actually. Joule is equal to what second? What else? Calorie. That's right. Başka bir şeyler daha yazılıyor. BTU. Kim? Yasin. Aferin Yasin. BTU herkes bilmez. British Thermal Unit. Özellikle doğalgazda, natural gas'ta filan BTU kullanılır. Ben de sevmem ha. Yani hiç işime gelmez BTU. Kafamda canlandıramam. I can't imagine size of it. For me, it's very clear. Kilowatt hour, megawatt hour, for example. Or Joule is also difficult. Joule is very small, actually. What second? What is a power? And if you give a work in watt, in 1 second, very tiny little, is joule. But there are a lot of reports giving joules. But some people say, I'm going to write here, TEO mu, TOO mu? Ton equivalent petroleum, for example. Ton equivalent petroleum. Some people still declare energy unit as a ton equivalent petroleum. Some people convert it kilocalorie, megacalorie. I would like to show you the units. Bakayım burada var mı? Yok, sadece bunları vermişim. Şimdi size o zaman bir dosya yükleyeyim. Orada vardı bu yükler. Bir dakika. Evet, yükledim. Biz bu sene bunun 2023 edition'ını takip edeceğiz ama yani bunun en arkasında ben buradan gideyim. En arkasında bir enerji conversion tablosu olması lazım. Hı, bu tablolar değil. Burada yok. Şu aşağıya bakayım. Evet, burada yok. Bulamadım çocuklar. Bu dursun, bu kalsın. Even you can't see me. I start I start from beginning. Come back here. These are primary energies. The first green ones, the solar, wind, geothermal, hydro, biomass are renewables. Although I'm a little bit skeptical about geothermal. Not very clear. Sorry, not very clean. I'm sorry. uh, they produce also some kind of material, bring the some kind of calcic materials to the earth anyway. Biomass also renewable. However, this is not very clean either. However, coal, oil, natural gas are fossil fuels. Particularly coal is a very, very bad energy source, which produce a lot of carbon dioxide, even some radioactive uh, emissions also produced during the coal fired. Anyway, nuclear is also primary energy. These are primary energies. Secondary energies, heat, mechanical energy, electrical energy. There are other chemical, pneumatic, other energies as well. Of course, the pneumatic energy is a pressure. The conversion is very important. If you look at the first one, wind energy, which is blowing in this direction, let's say, you can't see me, I'm sorry. Wind energy, if it's blowing like this, it rotates the turbine, and then of course that turbine rotates the generator, and that generator produces electricity. Solar energy, there are two types of solar. One of them is solar photovoltaic. Solar photovoltaic directly comes to the semiconductor material and produces electricity. It's called solar cell. However, some kind of solar energy with the kind of mirrors produce mechanical energy and then produce electrical energy as well. Of course, first produce heat for electrical energy production. First produce heat that mirrors produce excessive heat at a point, and then boiling the water and produce steam and things like this. Hydrogen plus oxygen, which is called fuel cell. Produce electrical energy, water, and heat. This technology might be used in electric vehicles as well. Hydraulic energy might produce mechanical energy than electrical energy. There are two types of hydraulic energy. You know, in dams, the water directly flows, and then those waters down rotates the turbines and then produce electricity. Generators are connected to turbines. Also, there are rivers where on top of the mountain you put a small reservoir over there and then drop the water. Then because of the mechanical energy produced because of the motion, then you rotate the turbines as well. We have also quite a substantial um, river energy as well. These are red ones are, of course, not very good. Coal, we burn down coal, produce heat. That heat produce steam, and then mechanical energy rotates the turbines, then generator produce electricity. Similarly, natural gas electric power stations, first of all, burn down natural gas, produce heat, mechanical energy, and electrical energy. Oil, for example, oil produce heat, then mechanical energy. Of course, electric energy in Saudi Arabia and some oil-rich countries, there are some power stations, but it's not very popular. Nuclear energy is similar actually. When nuclear reaction starts, it produces heat continuously. And also nuclear material, which comparing with coal, for example, very small amount of nuclear, uh, let's say, uh, sticks produce excessive heat. Then, of course, this excessive heat produce steam, and then because of that steam, turbines rotates mechanical energy, and we produce electrical energy. But we always need to cool down the excessive heat. We have to cool down the system. Do you know, is there anyone among you who knows about Fukushima nuclear power station disaster? Or perhaps you know about Chernobyl? I start with Chernobyl. I It was 1988 or 89. I don't exactly remember the date. You can look at your cell phones and you can write over there Chernobyl date. Then you can find the date. Uh, I used to listen shortwave BBC. Uh, we we we arrived in Turkey. We came back from United Kingdom at that time. We live in Istanbul, and I used to listen news over there. And then they said in Sweden the radioactive level is increased, and they say that there is a clouds coming, nuclear, containing some radioactive material in Sweden. Then we realized that there was something wrong with Chernobyl. Chernobyl is now in Ukraine. But what was happened actually? The first, when Chernobyl blow up, the of course the radioactive ash, let's say, or whatever it is, cloud, is getting up, then moving, first moving to the south and coming to the um, east part of Turkey, the northeast part of Turkey, Karadeniz region. And then when the rain comes, they drop. So all the plantations and everything, tea particularly, we have a lot of tea plantations over there, are contaminated with the radioactive material. Then wind changes its direction and goes to the north or west, goes to the um, Sweden. Then turn back again. I followed through the BBC news. The cloud turned again, and they entered to our Trachea region. We we stored a lot of cheese, milk. You see, since all the radioactive material drops on the grass, then the cows are eating those grasses. Then in their milk, there are high level of radioactive material. And particularly for matured people like us, is not very dangerous, but for kids, for particularly very small child, is dangerous, that milk. After 10 years or so, the cancer uh, figures are increased, particularly in the Karadeniz region of Turkey, because of tea. Tea is contaminated. Nobody understood that one, and they drank tea, I remember I was deputy dean at Istanbul Technical University. I was very young actually. It was um, it was 1889. It was 18. Sorry, I'm sorry. It was 1989 or 1910 or something like this. We were controlling. We used to have a nuclear energy institute at Istanbul Technical University, and nuclear energy institute always measure the radioactive level of the teas, tea leaves actually, and they used to find very high level. So that is what Chernobyl is all about. But in Fukushima, story is completely different. It was 2011. In 2011, I was following the energy figures of Europe, United States, China, India, and Japan as well. And I was very enthusiastic about the Japan's policy that since Japan, as far as energy, primary energy is concerned, similar to Turkey, Japan hasn't got primary energy much. All they have to import all the primary energies from outside, and that's why they decided that they at that time when the Fukushima accident occurred in 2011. Who's going to tell me what happened in Fukushima? Bakayım ne yazdınız? Var mı bir şey? Bitireceğim sonra dersi çocuklar. Yoruldum ben de. Fukushima accident. Electric failure. Yahya. What kind of electric failure was it? I tell you. There, there was a big earthquake occurred in the middle of the not far away from Japan in the but under the sea. Big earthquake. That big earthquake produced a waves, which is called, of course, tsunami. Those waves height was 10 meters. Then, of course, tsunami caused a lot of uh, problems, but particularly for nuclear power station is all about the the wall of the nuclear power station was I'm not if I'm not 100% sure 7 meter or so, but the tsunami level was higher than that. Therefore, the sea overtake the wall and gets in the nuclear power station, and the basement of the power station there were cooling electric motors are operating, and then they are cooling the nuclear power station. But when the flood comes in, electric motors couldn't be able to uh, cool down the nuclear power station, and then temperature rise, and then it blow up, and then produce a lot of environmental problems there as well. And before the accident, Japan was, I think, electricity production of Japan was something like it was 30%. I think 30% of electricity was produced by nuclear power stations, and they used to have a plan to increase that one to 50%. All of a sudden they cancel all the electric power stations, they close down, and now they are importing natural gas. They are, of course, increase the coal-fired power stations, and also they also invest a lot of on wind and solar now. However, the natural gas and coal were also envi- environmental problematic sources. That's what happened in 2011 in Japan. Now, however, if you nuclear policy is completely different one. When I was in 2002, I think, or before 2003, it was 2002. I was asked from Ankara Central Government Scientific and Technical Research Council of Turkey that I should become a chairman of the energy policy group for R&D, for research and development on energy. So 1 year I worked with almost more than 50 scientists and technical people in industry in energy business. And we prepared a report, R&D policy report for Turkey. During that report, I didn't touch nuclear. I said nuclear is completely different and special group should be formed to do that. And Turkey has also got nuclear power institute, atom enerji kurumu. We have a Turkey, and that power institute studied, and they decided favorable on nuclear power stations. So nuclear power is a controversial issue. In one hand, it is clean. On the other hand, it's very dangerous. So it depends how we can manage it. That is going to be my last sentences. However, I must add that in United Kingdom now there is a nuclear power station is under construction. 76.5% of the electricity is produced in France by nuclear power stations. And in Korea, China, Turkey, Vietnam, India, the nuclear power stations under construction. In Iran, of course, there's a political issue that one, so I'm not going to touch it. But Iran also has got nuclear power station. So it's a controversial issue. Some people says it is necessary in order to avoid those temperature level of the global temperature level problem. But some people says it's dangerous. Don't touch it. All right. So I'm going to take from this point. I'm tired. It's almost 1.5 hours I've been talking. Is there anyone who is going to add something to this? So I'm going to take Yasin Çelik is the last person. Abdurrahman Al Muslu is the first. Abdul Bari is the second one. Another Abdurrahman. Oh, Abdurrahman Efe Kork. I know him. Yes, we have Ahmet İsam, Amir Almaguz, Almazov, Atıl Yusuf Bozoğlu, Baran Edip Saatçıoğlu, all bildiğim isimler. İsimleri I know the names, but I don't remember the faces, unfortunately. Nasser, Muhammed Umar, Muhammed Ali Akbar. Don't leave. I haven't taken the attendance list. Nizam, Nureldin Muhammed, Wright, Tayyibe, Yahya, and Yasin. Just a moment. I must be sure that I have already taken an attendance list and put it that one. Open up. Don't leave. Evet, Yasin was the last person and Abdurrahman Al-Muslu is the first person. It's already stored. Therefore, now I come back to classroom. Yeah, that's right. Okay, next week, 9 o'clock. I'm going to start from that point. See you then. All the best. Have a nice weekend. Bye bye. Okay, thank you. Thank you. Thank you all. Bye bye.